Physics is all about understanding the mechanism of the universe and how it works. What are the fundamental building blocks which constitutes everything that we see around us? So far, we have achieved this trait by forming a tube of particles where different type of particles plays different role, but yet the standard model of particle physics isn't complete, waiting for the new discoveries that can complete it. And lepton flavor violation in the charge sector could be a key to achieve this dream. In standard model of particle physics, there are two kinds of particle. One is fermion, which is a matter particle and responsible for the creation of all different forms of matter that we found in our universe. And another one is bosons, which are force carrier particles. For example, two charged particles interact with one another through the exchange of photon, which is a quantum of light. Fermions are further classified on the basis of whether or not they participate in strong interactions. There are two groups of particles, one that do participate in strong interactions and another that do not. The group of particles that do participate in strong interactions are known as hadrons. For example, proton, neutron, and other particles which are further made up of quark and quarks itself. The particles that do not participate in strong interactions are known as leptons, and leptons are further divided as charged lepton and neutral lepton, which only interacts with the forces such as gravitational and weak nuclear force. These are key building blocks of matter and come in three different family or flavor. Leptons of different flavors have same properties except their mass, where electron is the lightest one, muon is heavier than electron, and the tau is heaviest among them. In the case of charged leptons, they also interact with the electromagnetic forces. In standard model of particle physics, there is nothing that connects the particles which belong from different families from one another. In other words, there is no interaction between the electron or muon lepton or tau or electron lepton or muon or tau. Does the lepton flavor is a conserved quantity? Not really. In phenomena such as neutrino oscillation, this seems to be broken. But what is a neutrino oscillation? It was observed through experiment that the neutrinos throughout journey can oscillate from one flavor to another. Let's say we have two detectors, one is placed near the sun and another is on the earth. As a large number of neutrinos were produced inside the sun, let's say we had detected one neutrino which was electron neutrino, and we expect that when electron neutrino reaches to the earth, it should be electron neutrino. But this doesn't occur. Throughout its journey. Electron neutrino oscillates from one flavor to another and changes from electron neutrino to muon or tau neutrino. It also depends on some factors such as how neutrino was formed and how it was detected. And when we finally detected, we found that it wasn't similar. From the past several years, a rapid improvement in the measurement techniques could be seen, and experiments like mu2e are still going on to discover lepton flavor violation in the charged sector to understand the truth of the nature.